Alright, so now that we have discussed basic probability with a coin toss, let's move on to a harder example. Let's use the probability of getting a 3 on a dice, which is an unlikely event. Now, a standard dice has 6 sides, from numbers 1 through 6. When you roll a dice, any of these sides is just as likely to come up as any of the others. That's really similar to flipping a coin. Just like the dice, with the coin, each side was just as likely to come up as the other. So, with this logic, you might expect the probability of rolling any number on the dice to be 50% or 1/2 as well, right? Well, that's not actually correct. We have to remember that there were only 2 possibilities for the coin, which was heads and tails. With the dice, there are 6 different possibilities. You can get numbers 1, 2, 3, 4, 5, or 6. So, since they have different possibilities, their probabilities can be the same. But how do we calculate this probability then? Well, if you think about what we did with the coin toss, it may give you a clue. We were looking for the probability of the coin landing on heads, which was one specific event. Let's put that on top of fraction. Now, since we had a maximum of 2 possible events with the coin, which were heads and tails, we can put 2 at the bottom of the fraction. So now, we end up with the chance of one specific event, the coin landing on heads, over the total number of events, which was heads or tails. This left us with 1/2 or 50%, which is the correct probability for a coin toss. We can do the same thing with the dice. We know that we have the chance of one specific event, which is 3 on the dice, over the chance of all the numbers we can get from the dice after rolling it, which are 1 through 6. Therefore, we can say that the probability of getting a 3 on the dice, which is one specific event, is 1 out of 6, because there are 6 possible events that we can get that 1, 3 from. And so this is roughly a 17% chance, which is uncertain. So simply put, I just found the chance of one specific event out of all the possibilities. See, it's much easier than it actually looks, isn't it?